Get ready to dive into something most of you probably don't think about too much. Asphalt.
Yeah.
The stuff our roads are paved with. I got my hands on some fascinating research about a product called RePlay, a soy-based asphalt rejuvenator.
Huh. Interesting.
And honestly, it's way more interesting than it sounds. We're going to be talking about the secret enemy that's slowly killing our roads, prematurely aging them, I should say. Why potholes are just the tip of the iceberg, and how soybeans and recycled materials could be the key to smoother roads and a healthier planet. So, to help me unpack all this science, I've got an expert here with me today.
Happy to be here.
So let's jump right in.
Yeah, so there's this hidden culprit. It's slowly degrading our asphalt roads. And that's oxidation.
Okay.
Think of it like this. Exposure to oxygen, UV rays from the sun, and even moisture. They all cause the asphalt to harden and become brittle over time.
So it's kind of like a loaf of bread going stale, but on a massive scale.
That's a great analogy. Just like stale bread. Oxidized asphalt loses its flexibility and strength, which leads to cracks, potholes, and that annoying raveling you see on the surface.
Right.
And it's not just an eyesore either. These issues lead to costly repairs and a much shorter lifespan for our roads.
Yeah, we're talking billions of dollars in repairs, right?
Absolutely, billions. And we've been trying to combat this oxidation problem for ages. There are traditional methods like sealers and petroleum-based rejuvenators, but they're kind of like putting a Band-Aid on a broken bone.
Yeah, temporary fix, not a long-term solution. Plus, those methods have their own issues.
Exactly.
Limited effectiveness, potential environmental concerns. So tell me more about this RePlay solution and how it's different.
RePlay is a fascinating approach. It tackles the problem at a molecular level. It was developed back in 2001, and it's made from 88% bio-based materials, with 40% being soybean oil.
Whoa, hold on. Soybeans to fix roads?
Yep.
That's pretty innovative.
Plus, it incorporates recycled materials. So it's taking a bite out of our waste problem, too.
Okay, I'm intrigued. But how does it actually work?
Well, RePlay penetrates the asphalt
Yeah.
and replenishes the oils that are lost during oxidation. But it doesn't stop there. It also introduces new polymers, specifically SBS and SBDS. They act like reinforcements, increasing the asphalt's flexibility, strength, and resistance to those damaging UV rays.
So it's not just patching things up, it's revitalizing the asphalt from within.
Precisely.
And what about the benefits?
The research suggests it could extend pavement life by 2 to 3 times,
Seriously?
reduce cracking and raveling, and even create a more water-resistant surface.
Wow. And what about the application process?
It cures quickly, has minimal odor, and doesn't require sand blotting like those traditional sealers.
That's amazing. Extending pavement life 2 to 3 times. That sounds almost too good to be true. Is there any evidence to back up these claims? What kind of research are we talking about?
That's the million-dollar question, right?
Yeah.
Well, they've put RePlay to the test in both field studies and laboratory experiments.
Okay, let's hear it.
We can dig into those if you're ready to see the science in action.
Absolutely. Let's start with the field studies. The white paper mentions some skid resistance tests on real roads in Ohio and New York. And skid resistance is crucial for safety, right?
Absolutely crucial, especially in wet conditions.
Right.
And the study showed RePlay either maintained or even improved skid resistance after application.
Oh, wow.
That's a big plus for safety and a good indication that this stuff actually works.
Yeah, for sure. What other real-world tests did they do?
They also did some water runoff experiments in Hutchinson, Minnesota, to see how RePlay-treated surfaces handle water compared to untreated ones.
Interesting.
It was a really striking visual demonstration. Water poured on the treated surfaces just ran right off, while the untreated surfaces soaked it up like a sponge.
Oh, wow. So it's like RePlay creates a shield that repels water,
Right.
preventing it from seeping into the asphalt
Right.
and causing further damage.
Exactly.
That's really cool. And what about other applications?
They also did a study at Tyndall Air Force Base.
Interesting.
Airports are incredibly environmentally sensitive areas, so finding sustainable solutions for pavement maintenance is critical.
Yeah, I can see why the Air Force would be interested. So it seems like these field studies show promising results, especially when it comes to safety and water resistance. But what about those lab experiments? What did they reveal about how RePlay works on a deeper level?
That's where we can zoom in and see how RePlay affects the asphalt at a microscopic level. They did a ton of tests, but one that stands out is the sand patch test.
Okay.
It measures the macro texture of the pavement and helps determine how well RePlay seals the surface.
And what did they find?
They tested samples from all over, from Saskatchewan to Florida, and the results were consistent. RePlay significantly reduced the number of voids in the pavement. It's like it fills in all the tiny gaps and crevices, creating a much smoother and more solid surface.
So it's not just about patching up existing damage, it's about preventing future damage by creating a more durable and resistant surface from the get-go. Interesting.
And to understand how effective that sealing is, they also did permeability tests, which measure how easily water can pass through the asphalt.
Oh, right. So did the water just beat up and roll off in those tests too?
Pretty much. The test showed a significant reduction in water penetration. After applying RePlay,
Okay.
they even used something called FTIR spectroscopy to actually see the RePlay polymers penetrating the asphalt.
Oh, wow.
It wasn't just sitting on top, it was becoming part of the structure.
That's impressive. Did they do any other tests?
Oh yeah, a whole battery of them. They put RePlay-treated asphalt through the ringer, testing its strength, moisture resistance, and resistance to deformation. The results were clear. Treated samples were significantly stronger, more resistant to moisture damage, and better at handling stress.
Yeah.
Compared to untreated samples, it's really changing the asphalt at a molecular level.
Wow, they really tried to break it, and replay-treated asphalt just kept coming out on top.
It did.
So they tested strength and all that, but did they actually look at the asphalt to see how deep the replay was penetrating?
They did. They got creative. Used black lights and blue light flashlights. It was like a CSI investigation for asphalt. They could see replay penetrating at least an inch deep, and they even found evidence suggesting it went even deeper than that.
Really?
The asphalt was temporarily softer at greater depths, and there was a noticeable citrus fragrance, plus some oil residue, all indicating the replay was working its magic.
That's pretty cool. So we're seeing positive results in both the field and the lab, but I'm wondering how this all plays out over time. Does replay hold up under real-world conditions over the long haul?
That's a great question. They did a long-term study in Douglas County, Nebraska, to investigate just that.
Okay.
They focused on a newly constructed 2-inch overlay, treating one section with replay and leaving another untreated as a control.
So they're basically tracking the performance of the treated versus untreated asphalt over an extended period to see how they hold up under real-world traffic and weather conditions.
Exactly.
Cool.
And they didn't just casually observe them. They ran a whole series of tests, including something called the Texas Overlay Test.
The Texas Overlay Test.
Yeah.
Sounds intense. What does that test actually do?
It's designed to examine fatigue and reflective cracking. Basically, how well the asphalt resists cracking under pressure. They used a bunch of fancy metrics to measure the results, things like cycles to failure, critical fracture energy, and the crack resistance index.
So it's all about seeing how much punishment the asphalt can take before it starts to crack and crumble. Did replay make a difference?
It did. The replay-treated sections performed slightly better than the untreated sections, showing greater resistance to crack initiation and progression.
Wow.
But that's just the tip of the iceberg. They also used a dynamic shear rheometer to analyze how the asphalt binder, the glue that holds everything together, was holding up over time.
Okay, I'm intrigued. Tell me more about this rheological analysis and what they learned about the binder.
Well, rheological properties just means how a material behaves under different conditions, like heat and pressure.
Got it.
And the dynamic shear rheometer measures specific properties of the binder, like its stiffness and elasticity. They found that the replay-treated binders showed less oxidative aging compared to the untreated ones, meaning they retained their desirable properties for longer.
So replay is not only making the asphalt stronger and more resilient, it's also slowing down the aging process at a molecular level.
That's what the evidence suggests.
Fascinating.
And to confirm those findings, they also did some detailed chemical analysis using Sarah and carbonyl testing.
Okay, break it down for me. What do those tests tell us?
Sarah testing analyzes the composition of the binder, looking at different components that affect its performance. And what's interesting is that they found a lower percentage of asphaltenes in the replay-treated samples.
Asphaltenes, remind me what those are again.
Think of asphaltenes as the heavier, more solid components of the binder. Over time, as asphalt ages, the percentage of asphaltenes increases, which can make the binder more brittle and prone to cracking.
Okay.
So the fact that replay-treated samples had fewer asphaltenes is another indication that it's slowing down the aging process.
Makes sense. What about the carbonyl testing? What did that reveal?
The carbonyl index is a measure of how much the asphalt has oxidized. They used a fancy technique called FTIR spectroscopy to measure this. The results were a bit mixed for some sections of the overlay, but overall the evidence points to replay's ability to reduce oxidation and slow down the aging process.
Interesting. So they're looking at it from every angle, from the physical properties to the chemical composition, and it's all pointing to the same conclusion. RePlay is doing something pretty remarkable to the asphalt. But what about cold weather? Don't roads tend to crack more easily in freezing temperatures?
You're right. Low-temperature cracking is a major concern. That's why they did a specific study in Clear Lake Riviera, California, to see how RePlay-treated asphalt performed in colder conditions.
Okay.
They used a bending beam rheometer, which basically measures how brittle the asphalt is at low temperatures.
So they're trying to simulate those frigid winter conditions and see how the asphalt holds up.
Exactly.
Got it.
And the findings were encouraging. RePlay-treated binders were less brittle and better able to handle stress at low temperatures compared to the untreated ones.
Okay, so they've thrown heat, water, pressure, and even freezing temperatures at RePlay-treated asphalt. And it's passed every test with flying colors. This is starting to sound like a miracle product.
Pretty impressive, right? But it's important to remember it's not a magic bullet. It's a tool that, when applied correctly, can significantly improve the performance and lifespan of our roads.
Right. So let's shift gears a bit and talk about the practical side of things. How is RePlay actually applied? I'm picturing some high-tech, futuristic contraption.
It's actually more straightforward than you might think. They typically use specialized agricultural sprayers, often mounted on the back of a pickup truck.
Okay.
And to ensure accurate application, they sometimes even use GPS technology.
So it's like a giant, high-tech paint sprayer for asphalt.
You could say that.
That's cool.
And for smaller areas like driveways and sidewalks, they can even use handheld sprayers, making it surprisingly accessible for a variety of applications.
Interesting. It seems like they've thought of everything. What about the curing time? I imagine shutting down a road for days while the stuff dries would be a major headache.
Fortunately, RePlay has a relatively quick curing time, typically around 20 to 30 minutes.
Wow, fast.
That means less disruption to traffic and lower maintenance costs.
Yeah, that makes a big difference. So no major road closures or traffic jams. What about the specifications for applying RePlay? Are there any specific guidelines or requirements?
Absolutely. They've developed a detailed specification that covers everything from surface preparation to traffic control, performance expectations, and even environmental stewardship.
Environmental stewardship. Tell me more about that.
They really emphasize the importance of using environmentally friendly products and minimizing any negative impact on the surrounding ecosystem. They highlight the fact that RePlay is a green product with a carbon-negative footprint, meaning it actually helps remove harmful greenhouse gases from the atmosphere.
That's fantastic. Not only are we getting better roads, but we're also reducing our environmental impact.
It's a great example of how sustainability and innovation can go hand in hand.
I agree. So we've covered a lot of ground here, from the science of oxidation to the impressive research backing up RePlay's claims. But what does this all mean for the future of our roads and our planet? Is this a glimpse into a world with smoother, longer-lasting, and more sustainable infrastructure?
That's a great question, and one we'll be exploring further in the next part of our deep dive.
Okay, I'm hooked.
Stay tuned, folks.
We're about to delve into the bigger picture and uncover the potential impact of this groundbreaking technology.
That's going to be good. Welcome back. If we think about the bigger picture here, we're really talking about a potential paradigm shift in how we approach infrastructure, maintenance, and sustainability.
A paradigm shift. That sounds pretty huge for just fixing potholes.
Well, think about it this way. If RePlay really delivers on its potential, we could be looking at a future with fewer potholes, longer-lasting roads, and less reliance on petroleum-based products.
Okay, yeah, I see what you mean. That would be huge, not just for drivers, but for the environment, too.
Exactly. Fewer potholes mean safer roads, less wear and tear on our vehicles, lower maintenance costs, and if roads last 2 to 3 times longer, that means less construction, fewer traffic jams, and fewer disruptions to our daily lives.
Right. So it's a win-win-win.
Absolutely. But of course, we need to be realistic. There are still questions to be answered and challenges to address.
Okay, sure. But let's bring it back to our listeners. How could this technology actually impact their lives? What difference does it make if a road lasts 5 years or 10 years?
Well, imagine this. Your city decides to repave your street using traditional methods.
All right.
A few years later, potholes start popping up, cracks appear. The road needs repairs. More construction, more traffic disruptions, and more taxpayer dollars going towards fixing the same problem.
Ugh, yeah, I've been there. So how does RePlay change that?
Now imagine the same street being repaved, But this time they use RePlay.
Okay.
The road lasts significantly longer, potentially 2 or 3 times longer, before needing any major repairs. That means fewer construction projects, smoother commutes, and less money being spent on constant repairs.
Gotcha. So fewer headaches for everyone. But what about the cost? I imagine using a new technology like RePlay must be more expensive.
It's a good question. While the upfront cost of applying RePlay might be slightly higher, the potential long-term savings from reduced maintenance and extended pavement life could outweigh that initial investment.
So you're saying it's like investing in a high-quality appliance
Exactly.
that lasts for years versus buying a cheaper one that breaks down quickly.
Precisely.
Okay, I get it. But do we have any numbers on those potential cost savings?
There have been a few studies that suggest significant cost savings are possible. For example, a study by the University of Minnesota found that using RePlay on a highway project resulted in a 25% reduction in lifecycle costs compared to traditional methods.
Wow, 25%.
And the National Center for Asphalt Technology estimated that using RePlay could save state departments of transportation an average of $14,000 per lane mile over a 20-year period.
Okay, yeah, that's a lot of money, so it makes sense economically. But what about the environmental impact? We talked about RePlay being a green product, but what does that really mean?
Well, let's break it down. First, using soybean oil as a key ingredient in RePlay reduces our reliance on petroleum, a finite fossil fuel that contributes to greenhouse gas emissions. Second, incorporating recycled materials like polystyrene helps reduce waste and keeps those materials out of landfills.
Makes sense.
And third, because RePlay extends the life of pavements. It reduces the need for frequent repaving, which reduces the overall carbon footprint of road construction and maintenance.
So it's a triple win for the environment. Less petroleum, less waste, lower carbon footprint.
Exactly.
But are there any downsides, any trade-offs we should consider?
That's a good point. It's important to look at the entire picture. For example, growing soybeans requires land, water, and fertilizer. So we need to ensure that soybean production for RePlay is done sustainably and doesn't negatively impact other agricultural needs or ecosystems.
Right, we don't want to create one problem while solving another.
Exactly. And while using recycled materials is fantastic, we also need to consider the energy required to collect, process, and transport those materials.
So there's a lot to consider.
There is.
Have there been any studies looking at the full life cycle assessment of RePlay to see if it truly is as environmentally friendly as it claims to be?
There have been some preliminary life cycle assessments that suggest RePlay does have a lower environmental impact compared to traditional asphalt rejuvenation methods.
Okay.
But more research is needed to fully understand the long-term effects and potential trade-offs.
So it's not a perfect solution, but it seems like a step in the right direction.
I think so.
Seems like we're at a crossroads where innovation and sustainability are converging, opening up new possibilities for how we build and maintain our infrastructure.
Absolutely. RePlay is just one example of a growing trend towards bio-based and recycled materials in construction. We're seeing innovations in everything from concrete to insulation, all aimed at reducing our reliance on traditional materials and minimizing our environmental footprint.
That's really exciting. But what can our listeners do? Do they just have to sit back and wait for their city to start using RePlay?
Not at all. They can be advocates for change in their communities.
Okay.
Start by learning more about the infrastructure projects happening in your area. Attend city council meetings. Talk to your local representatives and voice your support for sustainable solutions like RePlay.
So it's about making our voices heard.
Exactly.
And letting our leaders know that we care about sustainable infrastructure.
Right. And don't underestimate the power of spreading the word. Talk to your friends, family, and neighbors. Share the exciting possibilities of sustainable infrastructure.
It's all about raising awareness.
It is.
And creating a demand for these kinds of solutions.
The more people who know about it, the more likely it is that we'll see widespread adoption.
I agree. It's a collective effort.
It is.
This conversation has definitely sparked my curiosity. I'm already thinking about all the potential applications for RePlay beyond just roads. What if we could use it on parking lots, sidewalks, bike paths, even tennis courts?
You're right. The possibilities are endless. We're just scratching the surface of what's possible.
This is where it gets really interesting. But let's shift gears a bit and explore some real-world examples of how RePlay is actually being used today.
I completely agree. Let's delve into some specific projects where RePlay has made a real difference.
All right, let's get into some real-world examples of how RePlay is actually being used. Can you give us some specifics from the research?
Absolutely. There are a lot of examples. from small-scale applications to some major infrastructure projects.
Like what?
They've used it on everything.
Hmm.
Parking lots, city streets, county roads, even airport runways.
Wow, airport runways.
Yeah,
That's some serious traffic.
it is. And it's not just for roads. They've used RePlay on trails, sidewalks, even tennis courts.
Tennis courts.
Yeah,
Interesting. I guess those surfaces need protection too.
they do. They're exposed to the same elements. So RePlay sealing and protective properties are beneficial there too.
It really shows how versatile this technology is.
It does.
It makes you wonder what else they could use it for. What other potential applications are out there? Maybe rooftops to extend the lifespan of shingles, or even concrete structures to prevent cracking and water damage.
Those are some interesting ideas. It speaks to the potential of bio-based solutions for all sorts of infrastructure.
Yeah, it's pretty exciting. But let's talk practicalities. If I'm a city planner or a facilities manager, what do I need to consider when deciding whether or not to use RePlay?
The white paper actually offers some guidance on that. They mention several factors: the age and condition of the pavement, the climate, the traffic conditions,
Makes sense.
and of course the budget. They also emphasize working with experienced applicators.
Right, to make sure it's applied correctly.
Exactly.
So it's not just about the product itself, it's also about the application process.
It is.
So for our listeners out there who are thinking, this all sounds great, but could it actually work in my community? What would you say to them?
I would say don't underestimate the power of asking questions and advocating for change. If you're interested in RePlay or other innovative solutions, reach out to your local government officials, public works departments, community organizations.
Get involved.
Exactly. Share what you've learned. Encourage them to consider these options.
So we can all play a role in shaping the future of our communities.
We can.
Well, this has been a fascinating deep dive into the world of asphalt rejuvenation. Who knew there was so much innovation happening beneath our feet?
It's amazing what's out there.
It really is. It shows how human ingenuity can solve complex challenges, and that sustainability and innovation can go hand in hand.
I couldn't agree more.
It feels like we're at a turning point where we can move away from quick fixes and focus on long-term solutions.
It's an exciting time.
It is. Well, that's all the time we have for today. Thanks for joining us on this deep dive. Hopefully, you've learned something new and are feeling inspired to think about the future of infrastructure in a whole new way. Until next time, keep those minds curious.